In today's video, I am going to share you the exact questions that were asked in my Nielsen data engineer interview, and I will also tell you what they were testing in each one. Stay till the end because I will show you the hardest question I got near the end. Hello everyone, welcome to Big Data Factory. I am Pranit and I have over 4+ years of experience working as a data engineer. This interview was targeted for the candidates up to 3.5 years of experience, but this video will also help freshers and students as well, because the fundamentals they test are very important. So let me quickly explain how the interview was started. Initially, they asked me to introduce myself. I briefly spoke about my background, the companies I have worked with, and the real-time projects I have been involved in. After that short introduction, we directly moved into the technical questions. Firstly, they asked me to write code to count how many times the X appears in an array. This is simple logic. We initialize a counter as 0, then we loop through the array, and every time we see X, we increment the counter. That's it. And yes, Python has an inbuilt function to do that called count, but in interviews, they usually want to see your logical thinking, so writing the loop manually is better. And here, time complexity is often because we scan the array once. And then they asked me to write the Spark code to find the second highest salary according to the department. Now listen carefully, they didn't ask her to find the second highest salary overall. They specifically mentioned to find the second highest salary according to the department. This is a very classic interview question and you may find it everywhere. So how do we think? Firstly, we divide the data department wise. Then inside each department, we sort salaries in descending order. Then we pick the second one. The best way to solve this is using window functions. So here we are using dense rank with partition by department and order by salary, descending. Then we filter where rank is equal to 2. And you may get a question, why dense rank? Because if there are duplicate salaries, dense rank won't skip numbers. That's important. And then they asked a follow-up question, what is the difference between rank, dense rank and row number? This is a very common follow-up question if you use rank, dense rank and row number. So here I have explained with an example. Suppose if there are salaries of 4 different people, 100, 90, 90 and 80. So if you apply rank on it, rank will give you 1, 2, 2 and 4. If you apply dense rank on it, it will give you 1, 2, 2 and 3. And if you apply row number, it will give you 1, 2, 3, 4. So remember this clearly. Many candidates get confused here. Then the next question was interesting. They said, return a number from an array which when added with X gives Y. So think logically. If number plus X equals Y, then the number is equal to Y minus X. So first calculate target equals Y minus X. Then check if the target exists in the array. Very simple math. But interviewers are testing whether you can translate a problem statement into logic. Next, they asked about broadcast join in Spark. This is more real data engineering level. Broadcast join is used when one table is small and the other table is large. Instead of shuffling huge data across the cluster, we send the small table to all executors. That avoids heavy shuffle and improves performance. So in PySpark, we import broadcast join from PySpark.sql.functions, and during join, we wrap the small data frame inside broadcast. That's it. If you say in interview to avoid shuffle and improve performance when one table is small, that's a strong answer. Then they gave a cluster configuration question, and here they asked me to find out the number of executors, executor cores, and the executor memory required. So they said total 6 nodes. In that 6 nodes, 1 is master and 5 are worker nodes. So and here each node has 32 GB of RAM and 16 vCPU cores. So the first step is ignore the master. If we ignore the master, there are total 5 worker nodes. So here the total cores is equal to 16 multiplied by 5, which becomes 80 cores. And the total memory becomes 32 multiplied by 5, which gives 160 GB. But we should not use everything. We should leave 1 core and 1 GB memory per node for the operating system. So usable per node becomes 15 cores and roughly 31 GB memory. Now one good configuration could be 5 executors per node, each having 3 cores. That gives 25 executors in total. And executor memory will be around 6 GB. In interviews, they are not looking for one exact answer. They are checking whether you understand resource distribution logically. If you don't know how to calculate executor cores, executor memory and number of executors, let me know in the comment section below and I will make a dedicated video on it. Finally, they gave me an employee table which contains manager ID column, and they asked me to find the manager who has the highest number of direct reports. So what do we do? First, do by manager ID and count number of employees under each manager. Then sort by count descending and pick the top one. And after, join back with employee table to get the manager name. In the given example, John manages the highest number of employees, so output is John. Alright, that's the full set of hands-on questions that were asked in my Nielsen data engineering interview. And the big takeaway is this: they were not looking for the people who memorized Spark. They were looking for someone who can explain logic clearly, think about performance, and build pipelines that won't break in production. If you can confidently answer even 70% of what we covered today, you're already ahead of most candidates. Now, if you want me to make more such real interview question series or even a complete preparation checklist based on these exact topics, comment checklist and tell me your level, like other student or 0 to 2 years or 2+ years, and subscribe, because going further you will get more such interesting and technical content, so you don't waste months studying the wrong things. See you in the next video. Till then, bye bye.